finally got it correct. So here's the problem. A triangle is determined by 3 points in 3 space, and we're given that the points are A, 8 minus 5, 3. B is 1 minus 8, 1, 8. And C is equals minus 10, K, and 4. Now, to give you a preview, I've took the answers and used the liberty of and a little time to kind of graph all this. So if K, this one solution is K equals 1, and the other is K equals 117. Now, the fact that one of the solutions is 1, which is a precise answer, tells me I think that this is correct. I didn't check it. But so if K equals 1, then the points in red, A is 8 minus 5, 3, and B is 1 minus 1, 8, and C is minus 10, 1, and 4. And remember the area, I convert the area to mixed numbers, so it's 2, 1, 6 plus 1, 4, because I want to keep it intact in terms of fractions rather than try to use decimals, because it gets sloppy with decimals. Then you have to truncate the decimals and everything, and I prefer. So here's a graph of it. Here's a plane. I calculate the plane, and here's the 3 points: red, the blue, and the green. And green, of course, is minus 10, 1, 4. It's kind of flipped around. It's just trying to get an orientation of it. So here's the 2 vectors, and here's another diagram of it without the plane. There's the red vector and the blue vector. Now, we're going to use vectors in 3 space to help us simplify or to actually do the calculation. And keep in mind a couple things. Vectors in 3 spaces are denoted or symbolized by 1 column matrix. So if capital X is a vector, x1, x2, and x3, it's denoted by this 1 column vector. And if y, we're going to have both of these vectors. Y is y1, y2, y3. Now the inner product, dot product of, for example, xy is x1 times y1, x2 times x2 plus 2. Pretty straightforward. Now the product, dot product, assumes that these vectors all have tail or n at the origin, right? Now here's a situation. Our vector AB, which is the vector from the point A to minus 5, 3 to point B, 1 minus 1, 8, is not at the origin, but we do that by taking parallel translation to the vector x, which is then what we do is we subtract A from both of the points. So subtract A from A, we get the origin, and from B, subtract A, we get 1 minus 8, 1 minus 1, and basically the vector x, which is minus 7, 4, 5. Now I can visualize this one. Now the vector AC, in this case here, we're going to assume that k is the variable that, of course, we would just parallel translate that to y, which is which from the tail, from the tip point, we subtract the point A, which gives us y is a vector, is minus 18k plus 5 plus 1. Now, x and y are vectors in with origin, so that's okay. So here's what we're doing. So here's our vector from point A to B. We just parallel translate it to the vector x. Now, x is all at the origin, and it's pointing. You can see they're in the same direction, and the vectors being in the same direction, same length, it will work for our intent and purpose when we take inner product. Now, since we know that these vectors are in a plane, well, we want to calculate what's called, using inner product, the projection of the vector y onto the vector x. That's the blue vector. And by definition, the inner product of, or the dot product of xy divided by x, the dot product of x, times, that's a scalar, right? So remember, this is a scalar. Times the vector x. And then we want to calculate y minus the projection of x1. Now, this is the green vector, represents the height of the triangle. So let's summarize that in this little picture here. I drew it here. It's not on scale, but it summarizes, visualize, or give you a visualization what's the use of the projection. So here's vector x, not necessarily in pointing in this direction, and here's the vector y pointing, and they share the common origin. Right, here's the origin, and now the blue dotted vector is the projection of the vector y onto x. Basically, in geometry, what we do is we drop the perpendicular at the tip of this vector, or at the tip, or at this corner of the triangle, down to the base line of this triangle, right? And so that gives us the projection. Now, the orthogonal one is y minus this projection, and that's the green vector that we want. And so the calculation is here. So this is the green vector we want. We have, this is y, and this is projection, right? Of course, this is just y. Oh, dark on it. So that's what we need to calculate. And I'm not going to, it's not difficult, but it's very tedious and time consuming. I'll just kind of let the computer do the calculation for us. So I need to calculate first the blue vector, which is so it's inner product of x and y, inner product of x and x, times scalar times the vector. So here's the calculations down here, and you can double check if you want. The inner product of that, and then this is I call this vector y minus the projection y onto x as the orthogonal complement. That's usually known. So it's the vector y minus projection. And we calculate this. These are all two vectors. The first vector, it has a k in it, and the orthogonal complement has a k. Now, the orthogonal complement is a vector that will give us the calculation for the area triangle, because the area triangle is 1/2 the length of OC times the length of x. Now, length of x is just the square root of the inner product of xx, which is going to be square root of, if you calculate that's 7 square, it's 49 plus 16, which is 65 plus 25, which is 90. So it's the square root of 90. So the area triangle is, according to the summarizes, is 1/2 times the square root of OC, that's the length, and 10 times the length of the base. And we'll simplify. So now this here is this first calculation. First calculation is square root, of OC. And that's equals to exactly this term right here, which simplifies into this. Okay. All right. Anyways, here. Don't have to worry about it. It's right here. So it's 130. And if I didn't have my computer software do this, we'll be here for days. And it took me an hour to do all these manually and double check it. See, you can double check if you want. So this is 130. And then, of course, so the final formula for the triangle is therefore 1/2 times the length of OC times the length of x. And remember, that was equals to square root of 2. That was the area given, square root 1016. Now, all I did is set this up as equation, and it turns out it's a quadratic, and you just solve it. Or to simplify first to really see why it's a quadratic, you just square both sides and then take all the terms, appropriate terms across. You get that you're trying to solve for k in this quadratic equation, 740k squared minus 3080k plus 86990 is equals to 216 plus 14. It's a mixed number now. Divide by 90 times 60 squared. And in fact, you can see they both give us the same answer, which is k is equals to 117 over 36. Thank goodness there's no imaginary numbers. So I was running into a lot of issues because I couldn't get the numbers correct and I was getting imaginary answers. So now I know this is correct. So k is equals to 1, which we illustrate. And then the other answer is k equals 117 over 37. Now, I left out a lot of calculations, but I summarized the step-by-step calculations as best I could. You definitely don't want me to waste a lot of time, say, for example, calculating the inner product of the x and the y, right? And then you have to subtract that from the y, right? Okay. So now, if you feel free, if you think that you need me to expand upon this, remember this video, they require it to be under five minutes. And the truth is, math should be limited to about 5 minutes, because if you don't understand, if you can't make the presentation 5 minutes, then it's really mumbo jumbo as far as I'm concerned. So it's not math. I hope this works. I think that is it for the video, and I'll stop the recording.